Hello class, good morning. Our topic for today is measuring time and speed. So speed describes how fast an object moves. To find the speed, you must measure two quantities. First is the distance traveled by the object, and next one is the time it takes to travel the distance. So the formula for speed is distance divided by time. So different person, animals, birds, and cars, airplanes, they have what we call speed or average speed. So just like here, a walking person's average speed is 1.4 meter per second or 5 kilometer per hour, while for galloping horse is 19 meter per second or 68 kilometer per hour. Flying eagle is 51.01 meter per second, 184 kilometer per hour. So these are the speed of walking person, galloping horse, and flying eagle. Next is the speed of the things that we encounter in our daily life. For example, speeding race car is 96 meter per second and or 346 kilometer per hour, while for cruising jet is 257 meter per second or 925 kilometer per hour. So when an object covers equal distance in equal amount of time, it is moving at a constant speed. So just like here in our table, for time is 0, the distance is 0. For time is 1, the distance is 96. If 2, 192. So you can see that there is an equal amount of that an object covers equal distance and at an equal amount of time. So just like here, second and minute or second per meter. So in 1 second, 96. In 2 seconds, so 96 times 2, 192. So that's it. That the average speed is 96 or 96 meter per second. So most objects do not move with constant speed. The speed of an object can change from one instance to another instance. A useful quality called average speed can be defined. Average speed is simply the distance covered by an object divided by the time it takes to travel the distance. So for example, suppose a wheelchair racer finishes 132-meter race in 18 seconds. So calculate the racer's average speed. So average speed is equal to the distance divided by time. So the distance is 132 meter and the time is 18 seconds. So divide, the quotient is 7.3 meter per second. So the racer's average speed over the entire time distance is 7.3 meter per second. Since speed, distance, and time are related, we can calculate the distance and times by single arrangement of the formula. So if the distance is missing, speed times time. And if the time is missing, distance divided by speed. So for example, Cyrus drives at an average speed of 45 kilometer on a journey of 135 kilometer. How long does the journey take? So as you can see that this 45 kilometer per hour is the speed and 125 kilometer per kilometer is the distance. So since time is missing, distance divided by speed. So the distance is 135 divided by the speed, which is 45. So 135 divided by 45 is 3. Then just get, since the question is time, hours. Okay, 3 hours. Next is Danilo runs at an average speed of 8 km. If he runs for 6.5 hours, how far does he travel? So the missing here is distance, since the question is how far does he travel. Since we have 8 km per hour as the speed and 6.5 hours for the time. So to get the distance is equal to speed times time. So 6 kilometer times 6.5 hours or 6.5 hours, the product is 52 kilometers. So this is the distance that he traveled. So next is velocity. Velocity is describing the speed of an object. It's not enough. You may also need to know the direction in which the object is moving. By specifying both the speed and direction of motion, you can get the object's velocity. For example, um, 4.5 meter per second to the north or 2.0 kilometer per hour towards the highway. So you have seen the difference with the speed. There is a direction here: north, east, south, west. So velocity also is very important in knowing the speed and direction of a typhoon. So let's proceed to acceleration. When you pedal hard to gain speed on your bicycle, your velocity changes. It changes again when you slow down to stop. Your velocity also changes as you around curve in the road because the direction of your motion changes. So any change in velocity is called acceleration. So if the speed has changed, then that's what we call acceleration. And even if a certain object, do not increase in speed, but just like when you turn the steering wheel, your velocity changes whether or not your speed up or slow down as you make turns. So if even when you make turn, you are okay contributing, or there is a change in velocity, so that is another acceleration. So it is possible that things continuously change direction even there is no change in speed. Examples: these are the movement of Ferris wheel. So in the Ferris wheel, the same speed, but um, you are moving in a circular motion. Just like in a Ferris wheel, you are moving in a circular motion and the movement of the moon around the earth. So It continuously changes direction without changing its speed, and it is still acceleration. It is a common part of many types of motion. So that is acceleration. So for your activity, answer what to do on page 199. Take a clear photo of your answer and send it by private message. Deadline January 20.